Alright, in this lesson we are discussing extrema, the maximum and minimum values of a function. We have absolute maximum and minimum, which is the highest or smallest value of a function over the entire domain of the function. We also have local maximum and minimums, which is the highest and smallest values over some interval within the domain of the function. And the local maximum and minimum is also referred to as the relative maximum and minimum. It's also important to identify what intervals on a function is it increasing and where is it decreasing. A function is increasing when the line tangent to that function has a positive slope, and it's decreasing where the line tangent to that function has a negative slope. So if we look at a quadratic function, the graph is a parabola. That function is decreasing from negative infinity to 0. At 0 is the vertex for that parabola, and so it's increasing from 0 to positive infinity. Critical points on the function exist where that tangent line has a slope of 0, meaning it's a horizontal line, or where the slope is undefined, a vertical line. For example, on that same quadratic function, we can see it has a maximum value at that critical point, the vertex. That's where the tangent line is horizontal. There's a maximum at that point, and if we flip that parabola upside down, then we have a minimum value at that critical point, the point where the tangent line is horizontal to the graph. And then at this inflection point, we have the line that is tangent to the graph is actually vertical. So all those are critical points. From negative infinity to 0, that first function is increasing. From 0 to positive infinity, it is decreasing. And the second figure is decreasing from negative infinity to that critical point. And then from that critical point to positive infinity, it's increasing. And it's always increasing on this last graph. This first example, we want to identify the relative extrema. The relative minimum exists at -2, negative 5.5. Alright, that's where the horizontal line of the graph is. And there's a relative maximum at that coordinate 4, -2. The graph is increasing from -2 to 4, and it is decreasing from negative infinity to -2, and then from 4 to positive infinity. In example 2, there is a relative minimum value. There is no relative minimum value, since on both sides of the graph it goes to negative infinity. So there's no relative minimum. And the relative maximum exists at the vertex, which is at -2, 6. Again, the function is increasing from negative infinity to -2. And it's decreasing from -2 to positive infinity. And in this last example, we have a relative minimum at -3, 6. We have a relative maximum at 3, 11. the function is increasing from -3 to 3, and it's decreasing from -infinity to -3, and also from 3 to +infinity.